Welcome folks, it's Mike. Series circuit is the basic circuit that exists. All of the more complicated circuits, the parallels, the combination, everything gets turned into a series circuit for you to find your series for your voltage total and your current and your resistance total. So I used to tell my students, if you don't know how to play, if you don't know the rules, you can't play the game effectively. It's not that you can't play, because people play sandlot baseball and football and all that kind of stuff on a daily basis, but they couldn't use the same rules that they know from their backyard games and go and play in the NFL. And at the same time, the NFL, they know the rules and they can play this, the same game virtually, playing in Miami as they can and playing in Denver. Okay, the rules don't change because you went to your buddy's yard next door or the next neighborhood over or something like that. So it's the same thing with electricity. The rules are the same. It doesn't matter whether you're in America or China or South America. The rules of electricity stay the same. For this one here, in the series rules, we're going to cover this one here. It's going to be very short, but this is what's going to base, and I'll go into more detail on a series circuit and how we use these rules with that. Okay, so the number one rule is current stays the same in a series circuit. It never changes. Once you find your circuit total, or if you're given a problem and the circuit current is given to you, you don't have to figure out anything more in your Ohms Law to figure out the current in a series circuit. Okay, and this will make more sense to you here in this little bit here. Okay, the next one is all of the voltages used must add up to the circuit total. Okay, so in that example, if you're dealing with a 120 volt circuit and you've got three loads on there, three light bulbs, there's things called voltage drop, and we'll get into details on that, but the voltage drop across each one of those that they consume, that they are used out of that circuit, they have to total up to the 120 volts. And if you go through this as an example, because you know that, if you go and do all your voltage drops and your voltage drops don't come up to 120, let's say they only come up to 100, you've got a 20 volt voltage drop somewhere that you're losing, and that's probably why your circuit's not working. So that's how this is an application on why this works for you, because you're gonna go, well, I've got three light bulbs here, but they're all dim or they're not coming on, and you got a loose termination, okay? Or you got somebody that's wired something into that circuit that you didn't know about. But bottom line, that's the rule. If you have 3, 5, 15, it doesn't matter. Whatever the total is, and their resistances are going to vary. They may not necessarily all be exactly the same, but the bottom line is they all have to add up to the total. Okay. The third one is resistance is added. Okay. And that means if you've got three light bulbs in series, whatever the resistance, if one light bulb is 5 ohms, one light bulb is 20 ohms, and one light bulb is 25 ohms, you add them all up. 20 plus 5 is 25, and then the 25 plus the 25 is 50 ohms. So your circuit total for resistance would be 50 ohms. Okay, you get into parallel circuits, and it's a completely different ball game. It's not added up. It's a little more complicated for sure, but I'm going to show you how to do that and take the mystery out of it and make it to where it's easily understood. Okay, it's one of the things I really enjoy, is taking that mystery here out of the electricity. Okay, so number one, current stays the same. Okay, number two, all voltage used must add up to the circuit total. Okay, and resistance is added up for your circuit total. All right, so I'm going to give you an example real quick.